In the last episode, I used Win32 assembly. This was a really big mistake, so from this point forward I will be using Linux. Here is an ELF32 version of the program that I made in the last episode. Not much has changed, however, instead of EAX being the exit code, it is now the operation. Operation 1 is sysexit, and EBX is now the exit code. Int stands for interrupt, not integer, and now instructions like move no longer need a suffix for size, so no more move L, now it's just move. The first thing I'm going to cover today is sections. A section is like a different part of code that is there for different purposes. Like, for example, what is currently being done is done in the .text section. This is for executable code. What we will be talking about today is the .data section, which is for variable declaration and initialization. If you want to make an uninitialized variable, that will have to be done through the .bss section. Now, the way to declare a section is by saying section.data. And here we can start by creating a variable, but not so fast. Let's first make sure that everything that needs to be executed here is done in the .text section. So let's start by typing section.text. Indenting doesn't matter, it just makes it look pretty. It's not Python. Now, to declare a variable, let's start by giving it a name. I will call this hello_world. Now, the type I will be using is called data bytes, because if you didn't know, a string is actually just an array of bytes, which is why in C you can offset them with an index. So we will be typing hello world and then comma 10, because in the American Standard Code for Information Interchange, or ASCII, this is the new line character, and then comma 0. 0 is an invisible character, but it is very often used to find out where the end of a string is. Now we have our first variable, right here. So, how do we incorporate this, and how do we print it? Let's create some new lines, and then say move EAX, and then the operation code for standard out, which in this case is 4. Now let's move EBX 0, so 0 gets into EBX, and then move ECX hello world. But that's not it. You see, assembly doesn't really know that much, which means that if we just put hello world, it doesn't really know how much to print. So we have to make another variable for the length of hello world. Let's do that. Let's do len equals $, which means the address that this operation is performed, minus hello world. I'll explain a bit. Let's imagine that hello world gets run and declared on address number 7. The string is 13 characters long, so that when it gets here, it's on line 20. This is just the value 20. That's all this holds. And this, because it's the first index, will hold 7. If you minus the current position by the first position of the string, we get 13, which in fact is the length of the string. Feel free to watch that back or watch another explanation of this. I'm sure it might be a bit difficult to understand at first, but just figure it out. So, all we have to do now is move EDX len, and now we can finally interrupt 0x80. And there we have it. A hello world program made in assembly. Now let's go to a terminal and run this. If you're on Windows and you don't want to install a virtual machine, don't worry, because WSO exists. You can download it directly from Microsoft, and it works just like whatever distro you choose. So, let's now type nasm main.asm -f elf32 -o main.o. Now we'll link this, so we'll do ld-m elf _ i386 main.o main. Here we go. Now if we do /main, there we go. Thank you for watching. Goodbye. Subscribe, I guess.